Let's look at another case of special factoring, and in this case we're going to do factoring of perfect squares. So for this trinomial, what we need to recognize is there are three parameters that must be met for this pattern of factoring. The first parameter is that the a term must be a perfect square. So in this case, 49g squared is a perfect square with a root of 7g. The c term must also be a perfect square, and in this case the square root of 16 is 4. And the third parameter is that the second sign must be positive because you can't have a square root of a negative. So since all three parameters are met, the 49g squared is a perfect square, the 16 is a perfect square, and the second sign is positive, we can go on to the factoring. So here is our expression again, and we know that the square root of 49g squared is 7g. And the square root of 16 is 4. So for this factoring pattern, we're going to begin by putting a parenthesis set, and we're going to square that parenthesis set because this factor is a binomial squared. We begin filling the parentheses by putting the a root in, and this is 7g. We then add the c root in, the 4, and we always take the first sign. So in this case the first sign is negative, so our factor is the quantity 7g minus 4, quantity squared. So now that we've seen how to factor perfect squares in this situation, let's go ahead and factor one of the trinomials and solve for the variable. So our equation for this is 9d cubed plus 30d squared plus 25d equals 0. Now the first thing we recognize is that there is a d variable in each of the terms. So first thing we're going to do is factor out that d. And that gives us a value of 9d squared plus 30d plus 25 with the factor d on the outside of the parenthesis. So we now see that the 9d squared is a perfect square. That would be 3d. The c term is also a perfect square, 25. The square root would be 5. And we notice that the second sign is positive. So all three parameters are met. The a term is a perfect square, the c term is a perfect square, and the second sign is positive. So for our expression, remember we have factored out the d first. The a term's root is 3d, and the c term's root is 5. So we set up our parenthesis set again. So d on the outside, parenthesis quantity squared, equals 0. We begin filling the parentheses with the root of the a term, which is 3d. We then add in the root of the c term, which is 5. And for this trinomial, the first sign is positive, so our factor comes out as d, the quantity 3d plus 5, quantity squared, equals 0. So now we can begin the solving process. For the solving process, we must take each of the units that has a d variable in it and set it equal to 0. So the d on the outside makes it d equals 0. Because if d equals 0, 0 times that quantity would give us a solution of 0. We're also going to take the 3d plus 5 squared and set that equal to 0. And we're going to break it down to 3d plus 5 equals 0. We move the 5 to the other side, which gives us 3d equals negative 5. And we then divide by 3 on both sides, and we end up with d equals negative 5 over 3. Which means that we have solutions of d equals 0 and d equals negative 5/3. Now, because that 5/3 is squared, that's a double root. So it's actually d equals 0, d could equal negative 5/3, or d could equal negative 5/3 again. So the roots are 0, negative 5/3, and negative 5/3. So that is factoring and solving when you have perfect squares, and I hope this has been helpful.